So we have our thing we're trying to model. We have it in front of us so we can look at it, we can move it around, we can do stuff with it, see the sides of it. And we talked about selecting, translating, rotating, and scaling objects. And then yesterday we talked about selecting points, edges, and polygons and rotating, translating, and scaling those. And you probably came across something very quickly, which is that you wanted more detail. The technique we're going to learn about today is called subdivided surface modeling. The thing about it is, it's one of the few things in 3D that is exactly what it sounds like. I have a surface. If I subdivide it into more things, that's the technique. And it sounds very simple, but it's pretty complex. From the beginning of 3D, people wanted to model people. They wanted to model living things. And they couldn't. And you know why? Because it's all straight lines. If you've ever taken a life drawing class, one of the first things they tell you is there are no straight lines in life drawing. This was a problem. It was a problem big enough that if you think to the 1980s, all of the 3D was rocket ships and robots and tanks and other stuff that was like good, hard, solid edges. It wasn't until, what was it? It's a dinosaur movie, the big one, Jurassic Park. That was the first use of 3D creatures that were supposed to be living, first mass use of it. And they're not really living since they're dinosaurs, but it used a modeling technique that did not use straight lines. It used something called NURBS. You will hopefully never have to hear this again. NURBS stands for Non-Uniform Rational Bezier Spline. It's a mathematical description of a curve, and a single one is a NURBS. I'm going to show you something quick, because if you remember the 90s, there was a lot of really curvy design. This is a very good example. This was designed with NURBS. NURBS were descriptions of curves on top of curves, so you would get stuff like this compound curve on this compound curve on this compound curve. They really did not have the computer technology to do that before that. There's a big problem with NURBS. Graphics cards can't render them. Your NVIDIA, your AMD, they only render straight lines. So it was great for modeling, but if you wanted to animate something or move it, you still had to go back into polygons. Around 2000, an old technique called subdivided surfaces, computers got powerful enough to do it properly. They weren't before that. So if you wanted curves, you did NURBS, but they didn't really move that well, and everything else was straight lines. Subdivided surfaces enabled, it's still straight lines, that's the funny thing about it. It's just straight lines put where a curve would be. I'm going to show you a very good example of it here. This is later subdivided surface modeling technology. And signature of that is straight lines with curves on it. We're going to learn how to do this today. It's called a bevel. And there's one there, and there's one there, and there's one there. You couldn't do this with the NURBS technology. Getting straight lines in NURBS is very, very hard. There still are NURBS modeling tools. I'm not going to show them to you for so many reasons, not the least of which is that they're not used very frequently. They're available if you want them, but they don't serve much purpose anymore. And you can do most of the things you would have done with NURBS with subdivided surfaces. Okay, let's take a look at some of these techniques. I'm going to start with a primitive. That's where we always start, right? You know what? I'm going to try a primitive cylinder, and I'm going to do something. I'm going to get a unit cylinder. If I hold down Control, I can click this, and it will give me a 1 meter by 1 meter unit cylinder. I'm going to hit Shift and A. Let's talk a little bit about the stuff up here, because it's in every window too. This is showing me a wireframe, and that's because this says wireframe. It generally should be in default. There are other reasons I might want it in other places though. I probably want it in wireframe for some reason. You may have clicked this. This is which window it is. I can do all those plane views, top, bottom, right? It generally defaults to perspective. And if I click these double arrows, it gives me 4 of those windows. You'll notice they're all identical. I could change all the stuff in each of them. As a matter of fact, this is a wireframe one, and this is a default one, and this is a default one. I'm going to click this again to go back. I also should mention, if you click this gear, you get all the things that show up in the window. So if I want to turn off the grids and stuff, I can turn that off here if I want to, though I don't necessarily want to. But you could play with those things. This is an important thing about Modo, and it's unusual in software. In good 3D software, it's not unusual. Every single thing in Modo can be modified. And if you can modify something in Modo, you could animate it. Now I say that because I mean every edge of every screen, every color, every line, every bit of text, anything in here, if it's accessible, you have access to it. Nothing is held back from you. That means one can mess up the interface, but there's ways to fix that too. You go under layout, you go restore, okay, okay, and it defaults to how it came from the factory, which isn't a bad place to start anyway, all things considered. Okay, let's talk about subdivided surface techniques. I'm going to start, hit my 1 key in a vertex selection mode. I'm going to right mouse and we'll select these top vertices like that. Maybe I don't want to select all of them. I'm going to select every other one. I'm going to hit Control and I'm just going to click in between them to lose those other ones. And actually, I'm going to try something. If I use the up arrow, sometimes the up arrow will just automatically do the thing I'm doing, but in this case, that's not happening. So I'll go through and I'll actually make my selection. Now I'm just showing you this generically on an object, and you should probably do this before you use the tools, get used to how they work. If I go to vertex, these are all the various vertex tools, some of which we're going to learn right now. But I happen to know from a speed perspective, if I go close to a vertices and I right mouse click, I get a modeling operations window, which gives me all the quick modeling operations. I want to try this thing called a bevel. Okay, I click it and I get this slider and I get that. Now you see what that did is that turned 1 point into 3. That is a subdivided surface technique. Okay, good. Now I'm going to go to edge mode. Notice it has the things I had before selected, which is useful to me, but not what I want right now. I'm going to hit spacebar to deselect. I'm going to hit the 2 key. I'm going to select an edge there, and then I'm going to do something to get the whole loop. If I hit the L key, I select the whole loop. Now, if I right mouse click again, I could bevel an edge, which looks like this. Da, da, da. Now you see I can mess up geometry pretty badly with it too, so you'd want to be careful. A thing about a subdivided surface, which is kind of interesting, is that it puts new geometry in places that would approximate a curve. This is what I mean by this. I'm going to change the roundness level to 3 and watch this edge. See that? Now we know it's not really curved. It's really just straight lines, but it's straight lines where curves would be, and from a distance, it looks like a curve. Right? I'm going to hit the Q button, and I'll hit the 3 key, and I'll select this top polygon. I'm going to right mouse that, and I'm going to bevel the polygon. What does that do for me? That creates a new polygon, but more importantly, it creates all the geometry around it. What that means is I can do stuff like this. Let's push it back. Good, I'm getting an edge. I happen to know that shift and click gives me another one of the same operation. Though in this case I'm going to right mouse click and bevel it again. Okay, now you see I generated a whole bunch more geometry. with that. And that's just using the bevel command on points, edges, and polygons. I'm going to show you another thing for edges, because edges are what you end up beveling the most. And the idea of a bevel, again, is smoothing something off. I'm going to hit the 2 key again. I'm going to select this edge and then hit the L key to get that whole loop. And instead of bevel this time, I'm going to pick chamfer. Chamfer is a better version of bevel, as you can see. They rewrote it quite recently. I mean, like in the last 3 months. Bevel is okay and can do a lot of interesting things. That gives you an idea how curved we're talking about. And again, there are no actual curves there. That's all straight lines. There's a lot of controls in it. How many segments do I want to have? Do I want it to be round or do I want it to be square? I don't want it to be square. Sharp? Don't want it to be sharp either. I'm going to keep it round. I'm not going to tell you what profile is yet. You'll have to play with that on your own. What does reverse direction do? I'm just figuring these out as I'm clicking them, as you can tell. And generally, if it doesn't do what I want, I click it in a different direction. Like that. Okay, I'm going to hit A. This was a simple cylinder, and I beveled points, edges, and polygons, and I got a lot more detail to it. The trick with subdivided surface modeling is to put in just enough detail. Here's the thing, like if I'm doing an arm, like this part obviously could be like all one polygon, but here is where I need more, where it's going to bend. So generally when you're using subdivision techniques, you use them just to add a little bit of detail right where you want it. I'm going to pause that video there.